Hey everyone, welcome to my channel. My name is Brijesh. In this video, I'm going to show you how to define Lambda function with the help of Spring Boot application. We will also see what are the challenges with the Spring Boot application and to overcome those challenges if we can use some other framework so that our Lambda runtime as well as package size can be reduced. Let's get started. First of all, let's see what is Lambda function. Lambda function is a AWS service. Lambda function does not require a server running all the time. Whenever it is required, it will trigger Lambda function. It will boot up everything and then it will trigger the specific function. Now let's see how we can create a Lambda function with the help of AWS and then how we can provide the handler with the help of Java application. To create a Lambda, you can just search for Lambda and it will give you this window where you can define different functions. At this moment, we don't have any function, so we can define one function. Here, you can provide the name of Lambda function such as Lambda function or any name that you want to give. Here, you can provide the runtime. If you want to run the Lambda function with the help of Java application, you can pick Java. If you want to pick Node.js, Python, Ruby, .NET, etc. For different languages, it provides the runtime. That means whenever it will trigger a Lambda function, it will prepare the runtime environment for that function and then will execute the function that we are going to define. So here we are going with Java. If I search for Java, we have the latest environment Java 11. We cannot write any application which is higher than Java 11. We can select Java 8 or Java 11. Let's select Java 11. Let's not bother about any other setting at this moment. Here we have the create function. We have got our Lambda function created and now we can just provide different configuration. We can define the trigger points, whether we want to trigger this Lambda function from S3, from API gateway, from any other source. But at this moment, we will not do anything. We will just test our Lambda with the help of test. We need to provide some configuration with this Lambda. We have the Java 11 runtime. To execute this Lambda, we need to provide the handler. Here we have the example.hello class. Basically, this is a class with complete package and then the method of that class that will be called while this Lambda will be triggered. We need to define the class and then we need to write a method in it. This class can be defined in Java application or in any other application. We have specifically selected Java runtime, so we need to create a Java class. First of all, we will define one application containing this class and then we will upload that into the Lambda. Here we have created one Spring Boot applications. For that, we have the Spring Boot dependency. Then we have some of the dependency related to the Lombok for our getter and setter in our TT object. Then we have one dependency. This dependency is related to AWS Lambda Java core. With the help of this dependency, we will get some of the interfaces which are required to define the handler class. There are two ways to define the handler. The first way is to define the request handler and another one is the request stream handler. We have to implement one interface request handler. It takes two type parameters. First one is the input type and the output type. Input type could be anything. It could be object or it can be a custom type. Suppose here we have a requirement that we want to read this JSON from Lambda and we want to process that. For this type, we have a customer type. Here we have the customer ID, name and customer type. And this is the JSON that we want to read. In our handler, we can define customer. This is our input type. And then in the output type, we can define any type. Suppose we want to define a string type as a return type. When we do so, we just need to implement the method handle request. When we trigger AWS Lambda, it provides us one context object as well. And this context object holds the different information of the Lambda. We can get the logger, request ID, client context, function name, which has triggered this function. At this moment, let's say we just need a logger and we want to print the customer object that we have received. Also, what we want to return from this method is the string, which is a return type of our request handler. So here we can pass any string customer request. This is the first way where we have this API gateway handler and then it is going to provide us the handler request method. We have this API gateway handler which is under com.bridge. Here com.bridge.aws API gateway handler and then we need to provide the handler method which is handle request. This method we are getting from request handler. We can save this. At this moment, we have defined the configuration for this Lambda function. Now we have defined the code in our IDE that is not available here. So that code we need to upload, and that is what we can do in the upload from. We can either upload a .zip file or .jar file. We have this Spring Boot application. This is a Gradle based application, so we can generate the jar file from our build task. So here Gradle build. If we just check our build folder, and here within the lib we have got two files. First one is AWS snapshot jar and another one is plain jar. So this is the jar that has been generated from the Spring Boot application. Ideally, while running the Spring Boot application, we apply this jar. Now let's upload this jar and see what happens. So here we have the jar file. First of all, we will upload the snapshot.jar file. Here you can see it has 10.3 MB size, and if we save this, it has uploaded the function successfully. Now it's time to test this. Here we have defined our JSON ID, customer and customer type. We will save this event now. If we will test this, it will execute the Lambda and it has got failed. We have got the error, class not found, com.bridge.aws API gateway handler. Now let's look at the libs folder and see what could have been the problem. And if we just open it in Finder, unjar this. So here we have the content of the jar, and you can see it has got boot, inf, meta, inf, org. The directory structure it has, this is the problem for our application, because what we need was com.bridge.our handler class, but it does not have that. Snapshot jar will not work for us directly because it has the Spring Boot based structure, and when AWS will trigger our application, it requires the class to be called directly. So here we have plain jar. Let's see the content of this jar. Here you can see we have got the com, bridge, and the structure of our classes. This jar does not have any Spring Boot related dependency. It just have the plain classes which we have created by ourselves. We can use this plain jar. Here we can upload the jar, upload, and we are going to upload the plain jar. I'll save this, test our application again. It is again failing. At this time, it is failing for the log, factory, and other classes. Plain jar just have the classes which are part of our own code base. It does not have any dependencies. Again, there is a problem. To resolve this, we have the buildZip task that we can use, and this is available within the AWS documentation. Let's copy this task and paste it in our build.gradle. Execute the buildZip task. It has created the AWS application snapshot zip, and it has classes. It also has the lib required for this application. So it is the Spring Boot application, so it has all the dependencies related to Spring Boot, and then it has the log4j libraries. This is what we needed. All right, now you can see here we have 9.0 MB file. It has got uploaded, and if we test it again, we have the customer ID, name, customer type, new. So this is the first way. You might have a requirement where you want to have different JSON object to be processed by the Lambda. Then you will not be able to do that, because in the AWS Lambda handler, what we have done is we have provided the specific type. We might have different types that we want to process. So RequestHandler will not be able to help in that. Instead of that, we can use some other handler, which is StreamHandler. So here, instead of this API gateway handler, let's do one thing. I'll just create one class StreamHandler, and instead of RequestHandler, we can implement the RequestStreamHandler. All right. So it does not take any type parameter. However, we need to implement one method, handle request. So here you can see, instead of the type, here we are getting input stream. This is the input stream, that is stream of input that we are passing to our Lambda. Then we have the output stream. Here we are going to return the output from our Lambda function. The third one is the context, as we have seen here. So it will solve the same purpose. Now, only problem is within the request handler, the method that we have got, you can define your own type. Here we have got the input stream. From this stream, we can generate our response, and if we have different type of inputs that we are expecting, then we can apply different conditions, and based on that we can just define our own type. So here let's see how we can utilize this handle request. we don't need this anymore. So let's remove this, and here we have defined one build customer class. It takes the input stream. From this input stream, we are reading all the lines and we are writing that to the byte array output stream, and this stream we are eventually converting into string. Here you can apply different checks, what kind of object you want to convert to, and with the help of object mapper we are converting that to the customer object. For this object mapper we have applied the faster XML Jackson core data bind library. We have got the customer. This customer we can return in our application. Okay, build customer, we are passing this input stream, we are going to get the customer object. To return the output, we can provide output dot write, and here we can print response. Because this is the output stream, so we need to provide the bytes. With the help of both RequestStreamHandler as well as RequestHandler, we can execute our function and we will be able to process this thing. Here we need to change the configuration. Instead of AWS API Gateway Handler, now we need Stream Handler, and rest of the things are same. We will test it. Here we have got the output, and the output that we have applied into our output stream you can see here, and rest of the logs you can see over here. This is how both RequestHandler and RequestStreamHandler works. In the stream handler, whenever we are getting a customer, suppose we want to save this customer into database. For that we just need a service. We have one customer service that we want to use, and it does not have any fancy thing. It just have one notification service, and this service we have auto-wired in the customer service, and we want this customer service to be used in our Lambda function. Here in AWS Gateway Handler, we just need to define the customer service. So let's auto-wire it with the constructor. Here we can pass customer service. This dot customer service is equals to customer service, and we will just define the field customer service. From this customer service, we are going to call the customer service dot save customer method that we have, and we will pass the customer. Within save customer, we just have one log saving customer, and after saving the customer, it is calling the notification service to notify some system. We don't have any implementation so far except for the log. If everything goes well, we should be able to get this log, and we should also be able to get this log. We need to upload Lambda function again. We will test it. Here it says has no public zero argument constructor. You can see the problem. What it requires is the no arg constructor. We cannot apply the auto wiring based on the constructor. Instead of that, we need to provide the @auto wired. By default, it will have the no arg constructor. If we will upload it again, test it again, it is throwing the null pointer exception, and that is at line number 53. Go to the line number 53, and here you can see we are calling the customer service. This service we have auto wired, so it should be there, but it is not. When you define a Spring Boot application, here we have the main application. So when this method is called, it loads the beans that are there in the application, and if you have component scan, it will scan all the packages and then it will load those beans. This is when your Spring Boot application is running. Now the problem is when Lambda is triggered from the AWS, it only calls the method that we have defined as the handler in our Lambda configuration. It will instantiate this application, and then it will call handle request. That means it is not loading the Spring context. For that purpose, we would need to load the Spring context by ourselves. Same thing as we have done in our main application, we call this Spring Boot application run. Here we can just define the static application context. We might not have any arguments, so let's just pass the empty argument list to it. This is our context, that is what we are loading. And within constructor, we can get the customer service. Customer service is equals to context.getBean customer service.class. This is the bean that we will load here. Now what will happen? Whenever this application will run, it will load this static context. In the constructor, it will set the customer service. So just enable the service, and the customer service requires the notification service, which is again need to be a bean. And this time it has loaded the Spring Boot application, saving customer and customer creation notification. This is what we are getting from notification service as well as from the customer service. the bean injection has happened and we are able to use the Spring based beans. But only problem that you can see here is it has loaded this Spring Boot environment and then it has loaded all the beans. Also in the zip file, if we look at, we have got all the classes that we have defined. Here we have got the lib that contains the AWS based libraries, also the Spring Boot based libraries. Most of them we are not even using in our Lambda function. Even if we are defining a Lambda function, we should not be using heavy configuration in our Lambda. It should be doing some of the smallest tasks that you want to do. You should not require the whole set of libraries. Can we do anything else over here instead of Spring Boot? Just to utilize the dependency part. Instead of we write our own factory methods or factory classes, we can use some libraries such as Dagger or Jules, which can do all of these things for us, and we can just utilize our dependency injection instead of using the Spring Boot based application or Spring application. Let's see how we can add the Dagger dependency. We just don't want to use a Spring Boot anymore, and we will use the Dagger dependency. Okay, so we have two dependencies here. One is the implementation. This will give us the classes or annotation that we want to use, and then the annotation processor. This is going to process those annotation and it will create or generate the classes that are the representation of our factory classes. Now, because we are not using a Spring Boot, we would also need to apply some SL4J dependencies. So SL4J dependencies, one is this SL4J API and SL4J simple, which will have the implementation of the logger. Now, at this moment, we don't have customer service available within our context. So we just need to define some Dagger related components. We have two things. One is the module that we are going to define. We have the module class that will load all the dependencies. So whatever dependency we need to define, we can define under the @provides, and here we have the customer service and we have the notification service. If we need a singleton instance, we can just apply singleton. Here what we are doing, we have the provide customer service method and it requires the notification service. If you remember, we have notification service in our customer service. It will just give us the customer service instance because we need type of notification service. So for that, we also have @provides notification service. This is the dependency module. At this moment, we just have two dependencies that we need. Next thing we need is component interface. So here we have dependency component. We do require a @component. This is same as the Spring Boot component, but it is a Dagger component, which is coming from dagger.component. Now, within this component, we can provide different modules that we want to inject. Here we have the dependency module. It will build all the dependencies of the providers that we have defined within the dependency modules, like here customer provider, notification provider, etc. Similarly, you can have multiple module classes where you can have the modules specific to your different aspect. Within component, we have also defined one build customer method which just return the customer service. Similarly, we can define a notification service, etc. But at this moment, the notification service is going to be injected when customer service is going to be initialized. We don't need this thing at all. Let's just build this. Here we have got the generated file, and within generated file you can see we have got some of the component from the Dagger dependency component. We created a dependency component and it has created a class Dagger dependency component. With the method that we have defined, it has the customer service factory which is going to build customer service. In our application, we have to use this Dagger dependency component dot create dot build customer. So this is going to give us the customer instance. We have defined this constructor, and now Dagger dependency component dot create dot build customer is going to give us customer service. We don't need @inject over here because right now we are directly creating the customer from this Dagger dependency component, and this is the generated class, so it is creating the customer. Now within customer service, we have also added the @inject. Whenever this customer service will be initialized, this will also initialize this notification service. Now if I just build the zip, let's upload this. You can see it is just 2.0 MB as compared to the 9 MB that we have seen when we were using Spring Boot. If we test this, we have got successfully processed the request, and here we have the log for customer service and then for the notification service. Rest of the things are automatically auto wired. Like here we have customer service, within this we have notification service. So all the dependencies will be automatically created for us. It is quite useful when we are writing an application and we need the dependencies. We can use the dependency libraries instead of the whole bunch of framework like Spring Boot. The second purpose of Spring Boot could be the automatic configuration, right? So you have some environment variables that need to be configured. We can just define our configuration, and within environment variables we can define our environment variable. Here I can add any environment variable like test and test value. In our Lambda we can just use this anywhere. For now just add it here. We can just get it system.get env, and here we have the test. This is going to give us the environment variable test, and we can use it. If you don't want to read it directly from this, you can just create a configuration class wherein you will have a getter method, and for each getter method it will return the environment variable for a specific property. Second thing is, we have the complex dependencies that we want to add. So instead of keeping that in the application file, we can keep it in S3 file. The same way as we have converted this input stream into some object, we can also read that S3 input stream and then we can convert that into the object directly without writing lots of code. We don't need these Spring configuration properties as well. This is all about this video. I hope you enjoyed watching. Happy coding.